Welcome to the Tech and Space Leader Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Maxim Ismailov. He is the CEO and co-founder of Rocket Propulsion Systems, and Ankur Saxena. He is the COO of Rocket Propulsion Systems. Welcome to the show, Max and Ankur.
Yeah, happy to be here.
Thank you.
Absolutely. Thank you so much for making time to be here with us today. Perhaps we can start by having you each just give a little bit of background on yourselves and then an overview of rocket propulsion systems.
Yeah, so my name is Max Ismailov. I'm the founder and CEO of Rocket Propulsion Systems, RPS in short. We were founded in 2019, just turned 6 years of age this past week, which is a big milestone for us. What we do is we innovate in the propulsion field and flight vehicles, space vehicles that are related to our propulsion. Um, so we've been funded by the federal government for our innovations in propulsion and space technology since our founding. Um, Worked with NASA, National Science Foundation, and the latest partner that we have is the DoD, with the Air Force as a main leading end user and customer there for us.
Amazing. And Ankur, how about you?
Yeah, so actually, Max, did you want to introduce yourself, your personal
Oh,
background?
sorry.
Yeah, so, my professional background is graduated Purdue University with a PhD in space propulsion. Um, Worked at all the major new space companies of our time, Blue Origin, SpaceX. I was part of the small core teams developing booster engines for the rockets that are flying now to space. And yeah, shortly after that, started this company in 2019.
Wow, amazing. So let's talk a little bit about what you are bringing to market here. So, really, what is Rocket Propulsion Systems bringing to market that really addresses the, I guess, biggest missing pieces or challenges in the launch space?
Yeah, so the question on our mind every day as we come to work is how do we lower the cost of the space launch and orbital space systems once you're in space, right? The status quo right now is that there is large launch companies such as SpaceX and Blue Origin that make large vehicles, and there is rideshare option on those vehicles. But the problem is that a rideshare is like a big bus that takes you from Seattle to Chicago and drops you off in the middle of Chicago, and then you need to get to your little small town on your own, right? And that takes a lot of time and money. So the question is, how do we basically customize the space travel, right? How do we make the rockets smaller so that smaller businesses, just ordinary smaller businesses can afford them, start thinking about making money in space, right? Um, so how do we take those small businesses from Earth to the orbit and drop them off exactly where they need to be? Um, and this is what we're trying to do here. We're trying to hit below $2,000 per kilogram costs here at RPS, and um, basically everything we're doing, technologically speaking, is tailored to that sole purpose.
Wow. Okay. So it seems like a lot of launch providers have just been trying to get bigger, right, and carry more payload capability to space. And it sounds like you're going smaller. So how is what you're doing, I guess, otherwise different from other launch providers?
Yeah, so as Max mentioned, Lisa, the reason that we're trying to kind of go smaller and smaller as opposed to tailoring more to the larger payloads, which is what the space industry has predominantly done thus far, is because that's how some of these smaller businesses that have nothing really to do with space, but still want to make space a part of their business model in the future. That's how they're going to be able to access it. Many of these smaller businesses, and I'll talk about these smaller businesses in a moment, but many of these smaller businesses need these smaller size payloads. They don't have the resources, the capital, or even the need to build massive payloads to create huge constellations in space. Some of them may want to send just a couple of small sized cube satellites, for example, that fit in your hand, 2 or 3 into space, such that they can acquire data that they need and give it to their customers, who could be in a variety of different sectors. Apart from satellites, one of the other reasons that we want to bring down the vehicles and cater to small size payloads is because of a new up and coming ecosystem in space, generally under the umbrella of in-space assembly and manufacturing. And what this basically entails is that many different sectors, be it biopharma or novel materials, semiconductors, they want to move a part of their manufacturing process to space, because space offers a unique environment for the development of different types of products. And at a high level, why is there this environment is basically due to the lack of gravity in space. And due to the lack of compression and a variety of different benefits, it turns out that biopharma companies, for example, can produce human retinas, human hearts, kneecaps. The list really goes on. Novel materials involve semiconductor crystals, fiber optic cables, as just a few. And these are not huge payloads. These are small payloads, and they need to be hosted on small vehicles. And that's what we want to be able to provide, to be able to grow out this ecosystem in low Earth orbit, as well as medium and even higher deep space orbits. And we want to be able to provide this access to them in a simple and low cost way, without them having to think too much about the getting to space and back part of it.
Got it. Okay, so you talked a little bit about some of the examples of payloads. Can you go into a little bit more detail about the types of payloads that Rocket Propulsion Systems is planning to support?
Yeah, so roughly speaking, we are planning to support payloads on the order of 200 kilograms, roughly 400 or 500 pounds and smaller as a starting point. We want these payloads to be able to be, like I mentioned, some of those ISAM payloads, as well as, of course, smaller satellites, which is where we see the market trend going. Just this past week, over the last 2 weeks, I've had a chance to speak to several satellite companies who basically, tell us that right now their only options are the large primes, but ideally they want to be able to access more complex and more intricate orbits in space that right now the large primes are not necessarily catering to. So we are building a large part of our business around catering to the smaller payloads. However, due to the innovations that we're doing here at RPS, we are able to build our technology so that it is highly scalable. And so in the future, we certainly will have an option for the larger payloads. We don't want to exclude them, but as a starting point, we really believe that the small payload market is where the largest sort of gap is right now in space launch.
And just to harp on this point here was the ISAM. So we're talking about developments in 10, 15 years from now, right? 20 perhaps. So, just so you can visualize and your audience can visualize a use case, let's say there is an aging person who needs a heart replacement, right? That person may be able to order a heart to be 3D printed in space according to their specific DNA material. And then we basically host that payload, that printed heart and the printer itself on board of our orbital transfer vehicle. We make the heart, then we bring it back down to Earth, give it over to FedEx, and the FedEx delivers that heart to that aging person in about, say, a week. And that person doesn't need to worry about a donor that has a matching transplant. He doesn't have to wait in the queue for years. So that's what we're talking about.
And to this
Wow.
final point on this, we're seeing a huge collaboration to this end between biopharma companies and space launch companies, semiconductor companies and space launch sectors that up to this point never really had much to do with one another. It turns out that the collaborations now are starting, and we only expect them to grow, and we want to be able to support this effort.
Wow, those are fascinating use cases. There was something that you said, Ankur, as you were talking about the launch and being able to deliver payloads, I guess, to more specific places on orbit. Can you talk a little bit more about that?
Essentially, what I was trying to make is, I won't get too much into the exact specific orbits or anything, but what I was trying to say was that right now some of the larger primes, they're sort of like large trains that have a predetermined set of stops as to where payloads can be dropped off at. And based on the end use cases of customers, based on the end use cases, for example, of satellite customers, they may need to get to a new place in space to be able to gain coverage, to be able to perform coverage, or to be able to take pictures of an area of space that's quite far away from where the large prime drops them off at. So now there's the question of moving from where they were dropped off at to where they need to take these photos, for example. And it turns out that this travel here is a cost in itself. So when we talk about X dollars to LEO, a lot of the time it's assumed that, hey, that low cost X dollars to LEO will get you exactly where you need to be. Well, it turns out that the cost of that last leg of the travel can be as much, if not several times that cost. And that's what we're trying to do, is instead of getting from here to here, we want to take you right to there.
Ah, gotcha. Okay, that's amazing. When are you expecting to have test launches begin?
So building a rocket, of course, and building full launch vehicles is a process. We expect to do that. We are starting off our technology actually with what's called a suborbital rocket. So this is a rocket intended for launch just up to orbit, but slightly less than that. And this will kind of be a vehicle on our roadmap to full launch vehicles and our orbital transfer vehicles that Max alluded to in the beginning. So we are anticipating suborbital test launches in the 2027 timeframe, and a orbital transfer vehicle launch in 2028, with full launch from Earth to space coming in 2030 to 2032.
Okay, great. Well, it sounds like you have a great timeline there. When you talk about space flight, obviously you're seeing an opportunity for growth. What do you expect the growth will be over the next decade?
So yeah, Lisa, this is an interesting question, and our thinking here at RPS is contrary to the common opinions out there in the industry, right? Out there in the media, you may see a lot of news and news streams about colonizing Mars or going to the moon and building a base there on the moon. Now, we happen to believe at RPS that the next step for space is to really make it accessible to make business in space for small businesses, for ordinary people, right? We really think that space is going to move into this commercial, full-fledged ecosystem type environment, right? So we're not thinking that the progress is going to be to go to other planets. We are thinking that the space is going to serve us here, ordinary people on Earth. At least that's going to be part of the story in the next decade, and it's going to, understandably, some of the companies out there, the large primes, are going to perhaps move on to colonize Mars, but we believe that the space ecosystem, the commercial space ecosystem here on Earth, is going to complement that as well.
Ah, I see. So I think you've just sort of made your prediction, but I'm still going to ask you this question. So if you were to make one prediction about the future of space launch, what would it be?
Well, it goes back to my earlier comment, right? That it's not going to be just going to Mars or Moon. It's also going to be doing things that Ankur alluded to, right? Establishing those, building factories in space, establishing those little outposts in space. Basically, customizing space, right? Moving from the large, IBM machines that you had in the 70s down to personal laptops and mobile phones in your hand. That's what we're talking about, right? Moving from large buses and barges on the rivers down to small little scooters. That's what we're talking about.
Essentially,
Excellent.
just to kind of tack on, right now, space, when we look at it, when Max talks about these factories in space, we have buses, we have trains, and we have Lamborghinis in space, but we don't have Honda Civics. And Honda Civics is what are needed to make truly an infrastructure and an ecosystem accessible to all. Something that takes you exactly where you need to go for a low cost.
Okay. I love that. That is a great way to explain it. If someone wanted to learn more about rocket propulsion systems, what should they do?
So, of course, our website, rocketpropulsionsystems.com, is a great place to learn about what we're doing and contact us. Max and I are also both on LinkedIn, and we can also provide phone numbers and any other kind of contact information as well.
Excellent. Well, I want to thank you both so much for making time to be here today. I am really excited about the work your company is doing and can't wait to see you get off the ground.
Thanks, Lisa.
Thank you.
Appreciate the time.
Appreciate the time.
Absolutely. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.
Thank you.
Thank you.